Proposal topic it is the Kubernetes introspection, but recently inspired by the latest announcement of the Rocket and the IPC. So we are put a lot of effort, my team, and together with the CoreOS Rocket groups, especially Ifan, we put a lot of effort. We try to integrate the Kubernetes with Rocket as the one kind of the container runtime. And we're almost there. And we kind of totally got excited this morning about that keynote speech. So Eva and I quickly go over hack even more and make this whole things working. So then we decided to change the topic and talk about how we are going to run the Kubernetes Rocket, do a demo. So now I hand over to the Ifan. He quickly come up with a slides and talk about the high-level design of the Rocket and together with how much effort they put into the refactory. Okay.
All right. First, I want to thank you to Don for bringing this talk, and thanks for Victor, for Yuju from the Kubernetes node team make this possible. So some of you may notice the style of the slides are different. I guess we want to something new, so I bring this very simple style. Hope you enjoy. First is the brief of the Rocket. So Rocket is one implementation of the IPC spec. It has two major differences from the Docker. One is it's demoless, and why it's demoless is because we care about something like security. So you don't need daemons, so you don't need to run as root to run your containers or inspect your images. Also, daemonless helps you to update your containers without, like you can update your Rocket on your machine, but without tearing down your containers. And also the Rocket, the design of the IPC is pod-centric, because we think the pod is the only way to run containers as service at large scales. So, but it's very different from the Docker, from the current implementation from the Docker runtime in the Kubernetes. So how we handle this? For the demoless, although the Rocket is still demoless, but we still want to query for status and to start to kill containers. And so we do this by using the systemd. We create, for each pod, we create a service. And we systemd start, systemd control, kill, and using journal CTL to get the logs. And for the pod-centric, now we have, after a lot of refactoring, and now we have the pod-level interfaces in the Kubernetes for operating pods. So the current architecture looks kind of like this. Maybe the font is small, but I will explain. Basically, there are kubelets running in the nodes, and for each kubelet, now it has the container runtime to help it operate on the pods. So when the kubelet gets a pod update, or you create a pod, the kubelet receives the pod spec, it will pass the pod to the container runtime. And it's the runtime's job to figure out the difference between the old pod spec and the new one, and do the reconciliation, kill unwanted pods, or create new pods. And you can see now we have support Rocket and Docker as the runtime. And in the future, we also want to support more container runtime, more container runtimes like the LXC runtimes. There are issues on the Kubernetes GitHub talking about that. So here are the major interfaces now defining the container runtime. Like the most important thing, like the sync pod, which doing the reconciliation, and run in container and execute in container, which runs a single command in your container, and pod forward, which doing copying the output from the containers to your terminals. Okay, the current state of this Rocket implementation of the container runtime is we have the sync pod loop, the sync pod logic running. We have pods, volumes, capabilities, those stuff all working with Rocket containers. And you can also run and execute a command in your container, which we will show in the demo. And also you can get the pod status, you can get pod logs, and you can run containers as privileged containers. And we have basic GC, which one thing about Rocket is like we provide the GC for you. So now the Kubernetes GC is very simple. You just invoke Rocket GC. It will do all things for you. Okay, now I think it's the demo time. So for the demo, we will bring up a CoreOS cluster on the GC. Actually, we have already bring up it because it takes some time to do all the staging, to copy and uploading files. So yeah, and we will do start the pod, we will update the pod, kill the pod, and then execute some commands in your container and get the logs. Hopefully it will work. Yeah.
Okay, cross the finger. So I normally don't have good luck with demo. So, and also we just hack together, make this work half hour before this talk. But I figure if it's not working, and then I'm going to switch the topic to the Kubernetes introspection to debugging why it's not working. So we should be okay. So first thing I lied because we already bring up just half hour ago, we bring up the Kubernetes cluster on GCE. And oh, how's that? It's better? Oh.
Can you see that?
So now, first thing I want to show you guys are nodes, and I built a class, the CoreOS cluster with enable the Rocket by default, and also only have the one working node. And the master still running the default one. It's not CoreOS, it's not Rocket, because we have the more work, because that's the work in progress things. So, and I want to show you, hopefully this is working, but I'm not sure.
I think
just one.
Working.
Okay. And so normally the container runtime here should show the Docker, but because we hack together, we disable the Docker, so now nothing show there. In the future, for the introspection, we are going to give you the OS image and the kernel version, all those kind of information. And now let's start the pod, simple pod. Okay, good idea. Okay, here it is one simple manifest. Yes. This is one simple manifest, just similar to doing nothing and very too simple.
Yeah, and actually we can notice the images like have the Docker colon slash doc colon slash, which is a Docker image. So a nice thing about Rocket is it can run actually Docker images, and you can run Rocket image, you can run Docker image as your choice.
Please work for me. So now this is we have like the nginx pod scheduled to my perfect node, and let's try to see. Get the pods. So there are a bunch of the pods. It is the master component run as the pod, and then at the end, the last one is the schedule to my minion. There's the nginx, and right now it's
pending.
It's pending. Yes, this is pending. And to prove this is the CoreOS and Rocket, we are going to here. Can you see this one? We can see the progress here, I think. What's going on here?
Yes.
So still pulling the image and doing the preparation. So it's just sometimes pull image take longer time. I should cache the image.
Okay, yeah, good.
So now it's running. So we want to using this one to.
Yeah.
We want to using this one to demo the run in container. It works.
So Yeah, so for you who are not familiar with the Nginx Docker image, it actually contains a root FS and have a lot of, you can see the file system layout.
Okay, you can see.
Yeah,
Okay.
actually with this, we run a bash job in the Nginx container within the Nginx pod. So
let me log out. So we want to show you guys another example. We could correlate from the client, Kubectl control client, we could correlate the log of the running container. So to make this
happen, we need to run another example pod. That pod contains actually two containers. One is the Rocket CoreOS ACI, which is the Rocket container, and also it contains an Nginx, the Docker Nginx image. Right. I think we have created and we have scheduled the new pod, and it should be running now.
oh, it's so fast.
Yeah, because the Nginx image has already been pulled, so it's faster than the first time, and also because the CoreOS SCD image, the Rocket image, is so small, it runs super fast.
So from the minion side, you can see the Rocket show the list of the running containers, and here, and now we could do the log.
Yeah.
Please work for me.
Yeah,
Oh,
now we get the logs from the SCD,
At the CD server, yeah.
from the CoreOS pod.
Okay. This means Kubernetes works. And
And the last thing we want to show is we want to do a rolling update of the pod. Like, what's a rolling update? Is like you have your pod, you have your apps within your pod. Like you have two containers. One maybe some production one image and some backup image, and you want to like upgrade your production one image to like production two. And by doing this, you can just update your pod spec by rewrite your image, and the kubelet will do it for you. It will know you are doing update and will kill the old containers and update for the new containers.
I already created that new pod, and I forgot to show you guys the configurations.
Yeah.
This is really simple one, and then we can go to the machine. That work is killing me. You can see this is very simple manifest, and then let's go to the node.
Okay.
So we can first see this is running here. Yay, it works. Yes.
Yeah.
So now we can see that because that container actually writes some data to the temp file. So
we have made some mistakes. Like we are actually running the newer version of the containers. So we are now going to do a rollback instead of updating.
perfect.
Need more information about what the container doing. It's like bounding the temp directory of the host to the containers directory, which is foo and bar. And the container is actually writing files to its own view of its foo/foo directory, and the file just appear on the temp directory
This
of the
is
host.
weird. Wait minutes. No, this is weird.
Update R.
But this one, it is. So now let me update the image to the new image. Oh.
Sorry, yeah, we're running out of time.
Last one. Last. Okay.
Okay.
If anyone interesting, and I can show you guys offline.
Yeah. But you get the basic ideas. So we're quickly running out of time, and we want to also talk a little bit about our future plans.
By the way, first I want to show you how easy to run the, to start the CoreOS and with the Rocket as the. So you can see I only just can specify you need the cube distribution is the CoreOS, and also you specify what kind of the image it is, and then the container runtime is Rocket. Then just like the regular how you start the cube. The Kubernetes cluster, and then you just do the kube up, and everything is running. So, I think you want to talk about the. Let's talk about this. Yes.
Okay, so for next, we want to add more features to the Rocket. Like the Rocket has its own security verification methods. Like you need to use GPG keys to trust your image providers. We want to also introduce that concept into the kubelet. Also, we will have more finer grain resource control and the better integration with C advisors and more tests and yeah, refactoring the code. Thanks.
Okay, thank you guys. And if you have questions, and feel free to ask us offline. Thanks.
Thanks.